In this video, I'm going to show you how to prove that a transformation is linear. For this sample question, we suppose that transformation 1 v to w and transformation 2 v to w are linear transformations. We're going to let transformation 1 minus transformation 2 of x equals transformation 1 of x minus transformation 2 of x, and prove that the difference between the transformation is also linear. So when you're solving for linearity of a transformation, there are two functions that it has to solve. One is that it has to be additive, and the other is that it has to be homogeneous. The way that you solve for these terms mathematically is that for it to be additive, the function of x plus y must equal the function of x plus the function of y. And for it to be homogeneous, the function of some constant a times x must equal the constant a times the function of x. This is what you will be following to solve any transformation for its linearity. So in order to solve for this one, we are going to transform the format that the transformations are currently in into functions. That way we can just put them in here. So transformation 1 being v to w is the same as saying function 1 of v. The same thing for transformation 2. It is a function 2 of v. And what we are solving for is transformation 1 minus transformation 2, which we will define as just function of v. We know that this equals the transformation minus transformation of x, because that's what we defined, and it tells us that it is also equal to the transformation 1 of x minus the transformation 2 of x, which is the same as saying the function 1 of x minus the function 2 of x. So now that we have these definitions, we can start to just plug them into the needed properties. So we now know that the function that we are trying to find of v plus u, which is just two random terms like x and y, needs to equal the function of v plus the function of u. We know from here that this is the same as saying it is the function 1 of v plus u minus the function 2 of v plus u. And since we know that both function 1 and function 2 are linear transformations themselves, we know that they follow both of these rules also. So this is the same as saying, as expanding here for each of these. So f of 1 of v plus u is the same as saying f of 1 of v plus f of 1 of u. And then we subtract function 2 of v plus u, which is the same as saying function 2 of v plus function 2 of u. We will now rearrange this to solve for the v and u. That would be the same as saying function 1 of v minus function 2 of v plus function 1 of u minus function 2 of u, which is then, because of this, we know it's the same as saying the function that we are trying to find of v, because it's that, plus the function that we are trying to find of u. That's that. So since the function of v plus u equals the function of v plus the function of u, it satisfies the first property of being additive. We now need to solve for it being homogeneous. So for it to be homogeneous, the function that we are trying to find of some constant a times v needs to equal a times the function of v. Because of this property up here, or definition, we know that f of av is the same as saying f of 1 av minus f of 2 av. And again, since we know that both function 1 and function 2 are linear transformations, they again have the properties of being additive and homogeneous. So since they are homogeneous, we know that function 1 of av is the same as saying a function 1 of v, and function 2 of av is the same as saying a of function 2 v. We will now take out the a as a constant. So now, because of this again, this is the same as saying a function of v. And since the function of av equals a function of v, it also qualifies as being homogeneous. Since this new transformation of t1 minus t2 solves both being additive and homogeneous, the transformation is linear.